Hello everyone, good evening. This is Shatarupa and welcome to Biotecnika YouTube channel. So, कैसे हो आप सब? Hope you all are doing well. So, let me check one thing that am I audible? If I am audible, please type yes below in the chat box. Okay, Shivani has commented. Good evening, Shivani. Very good evening to you. So, am I audible? If yes, please type yes below in the comment section. Okay, fine, ma'am. Audible and visible. Okay, fine. Thank you, Shivani, for your valuable comment. Okay, so today is our second day live session of Nail the NEET Revision Series. So, hope you all are enjoying this session. So, today I'm going to take your chemistry session, and today I have come up with my topic that is thermodynamics. Okay, so before starting today's session, let me tell you one thing. Just after this session, don't forget to fill the feedback form, and the link will be given in the comment section, and after that also in the description box also. And if you want to know more about information about this NEET classes and all the any technical issue or anything query if you have, please reach out our team member through the email ID that is displayed over the screen. Okay, so just let's start today's session. So are you all excited? Are you all ready? If yes, then type yes below in the chat box. Okay, so many people is there. It's very interesting. Ankita, hello ma'am, it is audible. Okay, fine, Ankita. Nisha, hi ma'am. Hi Nisha. Shulabh, yes ma'am, you are audible. Thank you very much, Shulabh. Okay, so let's start today's session. So just start before starting, let me tell you one thing that I know of you, for all of you, the NEET aspirants, that you maybe think that thermodynamics is such a chapter that is mainly consists of so many numerical problems, mainly so many conceptual things. So maybe it's very hard for you all. But let me tell you one thing, this is gonna be very, very important topic. So don't forget to just read it, because you don't miss it. Because let me tell you one thing, that there is 45 overall question in the NEET examination, okay, for the chemistry section. For section A you will have 35 questions, and section B you will have the 10 question, and among those all, maybe around 12 marks question will be on this thermodynamics. It's very, very important. It carries almost 7 to 8% weightage in this exam, so you should not miss this. So that's why I have come up today this topic. So let's begin to this topic. Okay, so what is thermodynamics? Before telling that, I want to tell you one thing, that yes, what are the most important topic in this? Just 1 minute, because there may be some technical issues. Okay, now everything is fine. I think so. Okay. So some important topics are there. You should not miss that. Number 1, this is system, types of function, and process terminologies. Number 2, first law of thermodynamics. Number 3, enthalpy and enthalpy change. Number 4, bond energy or bond enthalpies. Number 5, heat capacity and bond enthalpies. Number 6, Hess's law of constant heat summation. 7, entropy and entropy change. Number 8, Gibbs energy. And number 9, third law of thermodynamics. Okay, so it's not possible in this small time to cover everything. So I will start with 1 and 2. Okay, so let's start. So what is thermodynamics? Thermodynamics क्या है बच्चों? Any idea? Yes. Thermodynamics basically is the study of effects between work, heat, and energy. So कैसे they are all related to each other. Mainly we are going to talk here in this thermodynamics, that is basically thermodynamics. Okay. So thermodynamics is a study of the effect of work, heat and energy and how they are interrelated to each other. We will teach here. Okay. So किसके ऊपर ये करेंगे? So on which we will perform our study. That is the system. So first we need to know about the system. So what is system? Yes, system is a definite quantity of matter. Yes, system is a definite quantity of matter which is mainly having a particular real or imaginary boundary and on which we focus mainly our study or the concentration, everything. So that is called the system. So suppose आपके पास क्या है? चाय के प्याले. So a cup of tea or a bottle of water. Everything is like we can say that is a system. System can be anything, a gas, a mixture of gas or whatever you can, on which mainly we perform our study. That is called the system. Okay. So next what? Yeah. System हो गया. हमने पढ़ ली what is system. Anything which are kept in consideration, that is called system. Now, what is surroundings? Just look upon this picture. If this is our system, then you can see that there is a perfect boundary, right? Boundary means a wall that may be separated the system from the surroundings. Okay, so what is surroundings? Anything external of the system, that is called the surrounding. Anything external of the system, that is called surrounding. So system के बाहर जो भी होता है, शायद let me tell you one thing. Suppose that is a cup of tea, right? So this is our system. Okay, so we are concentrating our performance or our everything. We are going to study everything on this system, right? So everything external on the system, everything is called the surroundings. And togetherly, the system and surrounding, togetherly, we will call that is the universe. Okay. So surrounding क्या हुआ? पता चल गया. Universe is what? Thermodynamic system plus surrounding, that is called the universe. So system plus surroundings, that is called the universe. Clear, everyone? Nisha, external system. Kriti. Hi, ma'am. Hi, Kriti. Welcome to Biotecnika channel. Papri, good evening, ma'am. Okay, good evening, Papri. Ankita. Yes, Ankita. So there are a lot of students. Hope you all are enjoying this session. So, okay, let's continue to the next session. Okay, so then we will talk about the wall. So that is the boundary. System ho gaya, surrounding ho gaya. Now we will talk about the boundary. So the wall or the boundary that mainly separated the system from its surroundings. That is called the wall or the boundary. Okay. Now boundary क्या होता है? कैसे type के होता है? So what are the mainly type of this boundary? So mainly there are two types. One is real boundary. Another is imaginary. Okay. So real boundary क्या होता है? What is real boundary? Real means anything we can touch, boundary or the wall. What is visible also and physically also and everything we can touch, we can feel that. That is the boundary. Okay. So let me tell you the example like a bottle. Okay. Or a cup of tea, everything. What is the boundary is there? We can feel that, we can touch that. That is the real boundary. Okay. And what is imaginary boundary? Suppose you have a particular beaker or anything and there is kept a particular liquid, suppose water. So, and that is open. This pot is open, completely open. So there you can see just this layer of water and the air of the atmosphere that is touched together, right? So between these two things, nothing, the boundary we can't see, we can't imagine. We can imagine, yes, definitely we can imagine, but we can't feel it that there is physically existence any such boundary or wall, right? That is called imaginary boundary. So this is the main type, that is what is real and what is imaginary boundary. But there are so many types of boundary also, wall. Okay. Number one type is that is diathermal wall. Diathermal wall. You know the meaning in this word, right? Diathermal wall means the boundary which mainly permits the flow of energy, which mainly permits the flow of energy or the heat between the system and the surroundings. That is called the diathermal wall. Okay, diathermal wall क्या होता है बच्चों? Mainly when the wall that permits the energy or the heat maybe that can exchange between the system and the surroundings. That is the diathermal wall. Let's take me an example, that is utensils. That is very good conducting material, right? So that can exchange heat, between the system and the surroundings. So that is a diathermal wall. Basically, the boundary in that we can say that is a diathermal wall. And another classification also there. What is that? That is adiabatic wall. Okay. So what is adiabatic wall? Adiabatic wall that means that does not allow the heat exchange between the system and the surroundings. When the wall doesn't allow allow the system to exchange its heat between the system and the surroundings, that is called the adiabatic wall. क्या होता है example? Okay, example is what? Thermoflask. Thermoflask is what the wall is such kind of that the material is used such kind of that it doesn't permit the exchange of heat between the system and the surroundings. So that's why adiabatic wall, it's a very good example of adiabatic wall. Okay, so got it everyone? Ankita, yes ma'am. Nisha, yes ma'am. Okay, thank you Ankita and Nisha. So stay tuned with us. Okay, now next. Now what is the classification of the system? So now we will talk about the type of the system. What are the basic classification of the type of the system? There are basically three mainly type of systems. Number one, open system. Number two, closed system. And number three, that is isolated system. Okay. So क्या होता है? Between mainly when we concentrate about the exchange of mass and energy. Mass and energy. So we will mainly concentrate about the exchange of mass and energy. Okay. So depending on this two things, we can say the systems will be three types. Okay. That is open system, closed system, and isolated system. So exchange of mass and energy between the system and the surroundings. So what is open system? Open system is when the mass and energy both are allowed to transfer between the system and the surroundings. That is called the open system. Okay. क्या होता है? When the mass and energy both are exchangeable between the system and the surroundings. Okay, so wall is such kind of material, it is built up with such kind of material that the system itself allows the exchange of matter or the mass, whatever we can say, and the energy both between the system and the surroundings. Then that is called the open system. Okay, what is the example? Yes, hot liquid in a beaker, a cup of hot tea. Everything is called an open system. Open system में क्या बोल सकते हैं? A bottle, water contained with water, right? Okay, a bottle, water bottle. If that is not covered, then we can say that is an open system. Because when it's not covered, then definitely the mass or the water or the energy or heat, everything, it can be transferred to the system and the surroundings. So this is what? This is an example of open system. Clear? Okay. Now, next, what is closed system? What is closed system? Closed system means when the mass cannot be permitted to exchange between the system and the surroundings, but the heat or the energy can be exchanged. But the heat and the energy can be exchanged between the system and the surroundings. Then that is called the closed system. मतलब क्या हुआ? Mass is not exchangeable between the system and the surroundings, but energy is exchangeable between the system and the surroundings. Okay, so then we can say that is a closed system. So what is the example? Pressure cooker. Obviously, it's an example of closed system because that is already covered. You know that when we will cook, so then obviously it is covered. And also closed water bottle. This is also an example of closed system. So when that whatever we have taken for our example as the open systems like a bottle, water bottle, when it is uncovered, then we can say that is open system, and when it's covered, completely covered, then we can say that is a closed system. Because what mass cannot be exchanged, but still it can be cooled down also, it can be heated also, right? You can see the temperature change, everything, right? So energy can be exchanged between the system and the surroundings. So that's why that is the example of closed system. Now, next move to the next slide. Yes, isolated system. Now, what is isolated system? Isolated system is such kind of system uh, when the wall of that particular system doesn't allow for the exchange of both the mass and energy. When mass and energy both are not exchangeable, between the system and the surroundings. Okay, then only that type of system we can call that is an isolated system. Clear, everyone? So when mass exchange will be allowed, that is open system. Mass exchange not allowed, but energy exchange can be allowed, that is our closed system. And then we can say isolated system means neither mass nor energy can be exchanged. Okay, so let me take a summary of overall the thing. You can see that the open system, here the mass transfer and heat transfer, yes for both. Okay, yes for both. Closed system means mass transfer, yes, but no heat transfer. But isolated system, mass transfer no and heat transfer also no. ये चाय की प्याले, the cup of tea, when it is open, obviously it is open system. When it is already covered, then it is also example of closed system. And when we can say that a thermodynamics, like the example of isolated system, that is a thermoflask. Okay. So everything is clear? I think it is clear for you all. Okay, Kirti. Kirti, yes, ma'am. Okay, Kirti, I got your thing that you understood already. Okay, now let's next move on. So now our next part is the properties. So what is a system? Sound is everything we have know. What are the type of basically the type of system we already know. Now what we will observe here, what we will basically measure in the system. So that is called the properties. The properties we will measure here. So there are the classification mainly between these properties. So they are mainly two types. Number one is intensive property and number two, extensive property. So properties which we will observe here or which we will study in this thermodynamic study mainly. So they are basically two types. One is intensive property and another is extensive property. Okay. So what is intensive property? So when the characteristics of substance that doesn't depend on the quantity, when the characteristics of the substance doesn't depend on the quantity of the substance, then we can call that particular property is intensive property. वो quantity के ऊपर depend नहीं करता है, then that is a particular intensive property. Okay. So what is the example? Okay, viscosity, density, these all are the example of this intensive property. Okay, why? You can definitely think like that this density, it is not possible that for a particular element or particular thing 2 grams have separate density and 5 grams have separate density. It's not right? It is not possible just. So we can say it doesn't depend on the quantity, right? So that's why this type of property we can say that is intensive property. And next is extensive property. So what is extensive property? Extensive property means a characteristics of substance that mainly depends on the quantity of the property. Okay, that mainly depends on the quantity of the property. When the property quantity के ऊपर depend करता है, then that is the extensive property. So what are those examples? Mass, volume, entropy. You know this that 2 ml volume, 10 ml volume are obviously different, right? So completely mass will be different also, right? So they are, so we can say this all are extensive property examples. Okay, so in that way, I will show you a very small tricks how we can recognize these properties. So there are also particular small tricks. Let me show you that thing. Okay, so very sorry. Actually, we were facing our technical and some difficulties. So where I was, okay. So yeah, I'm gonna show you a very small and very interesting trick that how we can differentiate between these extensive and intensive properties. So let me show you that things. Suppose this is our system. Suppose this one is our system, and you are measuring a particular property in the system. So if you think that, if you feel that a very small part of that particular system have that property, suppose you are measuring this property, okay, and here is. So if that property for a particular system, within that, a very small part of that particular system have the same property with the whole the system. If you see that that is equal to the whole system, very small part of that particular system which we are going to measure, so particular property for a very small part, if that is equal to the entire system, then we can say that is the intensive property. Suppose any property you can easily say like that, okay. Suppose the temperature, yes. So छोटी सी पार्ट अगर हम लोग कट कर ले, सो वहां पे अगर टेम्परेचर हम लोग मेजर करें, सो व्हाट इज यू कैन सी, yes, everything that the temperature will be equal with the entire system, right? It is just next to impossible to have different temperature in the small part and also the entire system, right? It is not possible. So we can say then the temperature is what? It is intensive property. Next, again we can say like suppose, yeah, density, obviously in small part which we have the density, also it will be the equal with the whole entire system, right? So then again you can say that is intensive property. But volume, we are measuring the small part, right? So is it possible to have the same value of volume for the small part and the entire part? No, right? No. You are agree with me? Yes. So definitely that is called the extensive property. So volume is the extensive property. Okay. So in that way, it is a very simple and easy trick. In that way, you can easily differentiate any of other quantity, any thermodynamic quantity or any other property. Okay. You can easily measure and you can easily say that either that could be intensive or extensive property. Yeah. In that way, you can say that intensive properties here I have given for you all the particular table, the temperature, melting point or freezing point, boiling point, density, hardness, molality, pressure, color, concentration, specific heat capacity. These all are intensive property, okay? And in similar way, extensive property, that is mole fraction or mole, entropy, energy, internal energy, Gibbs free energy, these all are extensive property, volume, mass, everything. You have different mass also here and also in the system, right? So also this is also called, we can say that is extensive property. That's how you can easily differentiate of every properties, right? Okay, Nisha, heat capacity. Okay, fine, Nisha. Yeah, Thiran. Okay. I don't know what you have written in the comment section. So if you have any queries, definitely you can again type there, okay? Okay, fine. So let me move to the next part. Okay. So there you can see that all of I have just made for you all that you can easily differentiate the intensive and extensive property. And again, let me tell you another and very small and easy trick that how you can differentiate those. If you see any particular property, that is a ratio of to extensive property. Ratio of to extensive property. Then just trust me, that property will be definitely, just blindly you can trust that property will be intensive property. If any property you can see that is basically a ratio of both the extensive property, then definitely whatever you are getting as result, that is the intensive property. So remember this thing. Example, yes, example is like, we can say like density, right? It is an intensive property. How we can show you that this is a ratio of two extensive property? Density is basically mass by volume, right? So both are extensive property. That's how you can say it's an also intensive property. Similar way, you can see that molarity, right? So molarity is an intensive property. How? It is basically ratio of mole of the solute, that is extensive property, and another is volume of the solute. That is also extensive property, right? This is also another trick you can easily apply and you can easily differentiate. Okay, clear everyone? Okay, so let's move to the next part. Now we'll be talking about the functions or this elaborately about this properties. So what are the basic classification of this function, thermodynamic functions? There are basically two types of functions. Number one is state function, okay? And number two is process function or the path function. So what are the two types? That is state function and the process or the process function or the path function. So just look up on this picture. This is very interesting. You're gonna enjoy it. So the thing is, at the top of this mountain, how you can reach there? At this top of this mountain, how you can reach here? Yeah, there are two ways, right? Number one, you can easily go straight and you can choose this path and you can easily reach there. Maybe it's not easy, I know, just to climb on the mountain, but still, you can have this way also. You can choose this. Or else you can do what? You can choose any curved way, like this pathway, the red mark there, okay? So that's how in another way you can also reach to the mountain of this top, right? So there are lots of way you can reach. So when the thing is, when just if it is your destination, just to reach over this mountain, right? So you can follow any path. So what is state function? That is when a particular property or the value doesn't depend on whatever the path you have chosen. It mainly depends on the initial state and the final state. Okay. When a particular property mainly depends on the initial state and the final state, it doesn't depend on the path you have chosen to reach there. Suppose it's this curve or this straight line. Doesn't depend. So then only then we can say that particular function is called the state function. Okay, clear everyone? So any thermodynamic functions, all are state function. All are state functions means this internal energy, that's H means enthalpy, gives energy G, S is the entropy, temperature, volume, everything. These all are we can say that is all are state functions, except two, that is work done and Q, that is heat. Okay, only except two, all the thermodynamics functions are under the state function. Remember everyone? So that's why this state function is mainly dependent on two states, that is initial and the final state. So that's why we can call that state function is, as we can say, it's a point function. Okay, another name is point function. So if you have been asked in the question in your exam, suppose point function, they're asking about point function, but instead of state function, please don't be confused. This is mainly nothing but the state function. Okay, clear everyone? Okay, so now we will talk about the path function. So what is the path function? Yes, when a particular function or that value mainly depends on the path whatever we have chosen to reach the final destination. Starting from our initial point, if we want to, of our final destination, we want to reach there. And if that particular property or the function is very much dependent on the path which we have chosen there. Okay, so if that is completely dependent on the path, either the straight line or curve or whatever, then we can say that function is called the path function. Okay, so all the thermodynamic terms you can see, like internal energy, temperature, volume, pressure, everything is state function. Okay, but only two are remaining, that is work done and the heat, Q. Okay, these two are only the path function, and whatever is all other thermodynamics properties, is all are state function. Okay, so let me tell you another one tricks that how you can understand all the thermodynamics property which is starting with this delta sign. Delta, you know the delta, this Greek letter delta. Delta means very small difference of any particular property. That may be temperature, that is delta T. That may be your pressure, delta P, that is change of very small pressure, we are talking about that. Or if you can say like the change of very small change of internal energy, delta U. Enthalpy, delta H. So any property that mainly going to start with this delta sign. So these all are under the state function. Only which are the path function. So please listen carefully. Only which are the path function we don't use this delta sign. That is W and Q. Okay, we never use this delta sign before starting that, because state function means only depends on the initial and final state, right? So it's only depend on the difference of the values. So that's why we easily use this delta sign here. But W or Q, whatever this work done and heat, this doesn't depend on only on the initial and final state. It's completely depend on the path what we need to choose. Okay. So that's why this is also another way how you can say that path function and state function you should also remember. This also take a small trick how you can remember. Okay. So this is all about our functions. Okay. Now we are going to talk about our first law of thermodynamics. So what is this first law of thermodynamics? So first law of thermodynamics is basically the extension of the law of conservation of energy, law of conservation of energy. How it is the extension? The law of conservation of energy, there we all know that is the energy, we can't generate it, or we can't produce it, or we can't destroy it also. Only what we can, only we can transfer from one mass to energy. We can convert it from one form to another, right? So that is the thing. This is also, we can say, the extension of first law. Okay, the extension of the conservation of mass and energy. Okay, so how it will work? When we are providing particularly heat to a particular system. Okay, suppose we are providing Q heat to a particular system. So what they can do now? So there is two type of work actually. Number one, the part of that heat that can convert into work done into the system. Work done of the system. Okay, that can convert into work done of the system. Another way, what we can do? Another way, when we are introducing the Q, the another part is that will increase the internal energy of the system, right? That is U. Right. So when we are heating a particular system, then there is two way. What is going to happen? One part that can convert into an work done in the system, and another part we can say that is introducing, or we can say the increase of the internal energy going to happen there. Right. So that's why we can say now the entire internal energy U, that is basically the summation of this Q, the heat what we have already provided, and the work done of the system. This is what the first law of thermodynamics. This is called the first law of thermodynamics, that is U means that basically we can say delta U, the change of internal energy. Basically it is the summation of the heat what we have provided in our system and the work done of the system. Now definitely just listen carefully. Now you have to remember the sign convention. This is very, very important. So work done has basically two type of sign convention. One is positive and another is negative. So when we think like that? So the system is work done basically happen like that. Suppose you have a particular mixture of gas in a particular pot. Okay, and there is a piston. Suppose this is a piston over it. Okay, so piston is, it can be moved down also, it can be up also. Okay, so this can move easily. So there is a gas mixture you have. So what you can do, our system is what? Now this is our system. Okay, this is our system. Now piston can go down also. How it can go down? When we are just, suppose we are increasing mass over this particular piston. Okay, then what is going to happen? The piston will go down. Now it will come here also, right? This new one, here it come here also. So then we can say that the gas is compressing, right? So gas itself, that is compressing in volume, you can easily see. So mass is just we have put down over the this piston, and that is piston will be going down. So what is happening here? Here we can say the work done on the system, because our system is gas, right? So work done is performing on our system, on the system. So when that is work done on the system, then we can say the sign convention for this work done is positive. Work done on the system, okay? When work done on the system, we can say that is positive. Or else what we can see there, that suppose now we are removing this mass from here one by one. Now what is we can see? We can see that piston will again come up, right? It can again come up into the previous position also, or more also another, it will again increase its height, right? We can see. So now what is happened? We can see that the gas itself in the chamber, that is now again expansion is going. So it is now expanding, right? Again, the expansion of gas we can observe. So now what is happening? We can say now the gas done by the system is performing, right? The gas itself performing the work done, right? So that's why we can say the work done by the system. So when the work done by the system, then W will be negative. So work done by the system. Okay. So there is two type of convention, what I have said, that is positive and negative. Work done on the system means that is positive. Work done by the system means negative. So just in that way, you have to remember and you have to use your first law of thermodynamics. So when you can see the change of internal energy, it will be Q plus W when work done is here. The work done is on the system and it is minus, right? The sign convention is negative when work done by the system. So in that way, you have to change your equation and you have to use in your numerical problems while solving. Okay. Okay. So this is what I have said. You can see here also. Priyanka, yes, ma'am. Kirti, yes, ma'am. Okay, fine. Priyanka, Kirti, thank you for your valuable comment. Okay, so you all are enjoying and you all are understanding all this thing. This is a lot for us. Okay, so next we can say what we are now getting as the information from this first law of thermodynamics. Okay, not what we are getting from this as a result of this thermodynamics of first law. Okay, so you know that is delta U equals to Q plus W. Right, this is our first law of thermodynamics. So now, number one, if no work is done, if there is no work is performed, so then we can say W equals to 0. W equals to 0. Okay, so W equals to 0 means you can say from this first law of thermodynamics, what? W equals 0 means now you have delta U equals to Q. Right? Delta U equals to Q. Whatever you have provided the heat in the system, that is basically equal to the change of internal energy in the system when the work done is 0. So what is that process we can call? This relation is true for what? Isochoric process. This is called isochoric process. There is this type of relation is following. Okay. So what is isochoric process? Isochoric process means when there is no work done and basically we are getting the Q is, or the heat, it is a value of heat is equal to the change of internal energy. Then we can say this equation holds very good for the what the isochoric process. So isochoric process is what? Isochoric process is such kind of process where the volume is basically kept constant. Volume is constant means delta V is constant. How we can show you? Just let me show you one thing. If there is delta U equals to Q, right? And we can say no work done, W equals to 0. So what is the formula of work done? You all know. What is the formula of work done? Work done is basically in general. Just don't concentrate on the work done on the system or by the system. Don't concentrate on this function as a whole. Just generally, what is the work done formula? You know what is the work done formula? W equals to minus P into dV. That is volume change. So minus P into volume change. That is V2 minus V1. Okay, so now you know W equals to 0. You already know here the W equals to 0, right? So W equals to 0 means you can say PdV equals to 0, right? This PdV equals to 0. So delta V we can say equals to obviously 0. That is, there is no change of volume. The volume is keeping constant there, right? So that's why we can say this type of process is called isochoric. So isochoric process means there is volume is constant, right? P plus V, what you have said, Kriti, I couldn't understand your comment. You can again comment, okay? Okay, fine. So this is what? Now next. what we have got here from as our information. Number 2 is if there is no exchange of heat between the system and the surrounding. If there is no exchange of heat between the system and surroundings, that is Q equals to 0, right? That is Q equals to 0. Now what we have about from this first law of thermodynamics, what we can write? If Q equals to 0, then easily we can write that is delta U equals to W, right? Delta U equals to W. That is what is the work done on the system or by the system, that is basically equal to the change of internal energy, right? So this relation is true for what? This relation is true for adiabatic process. Already I have talked about this in the previous slide, right? Adiabatic wall. Remember, adiabatic wall means the wall is such kind of material, it is built up with such kind of material that there is no exchange between the system of heat between the system and the surroundings. That is called adiabatic wall. So that type of process also, this type of process, we can say that is adiabatic process. So the wall is basically there, adiabatic wall. So there is no exchange of heat between the system and the surroundings, right? So this is called adiabatic process. Clear? So this information also we have got now. Now number 3, if there is no change in the internal energy of the system, if there is no internal energy change of the system, that is delta U equals to 0. So now when the delta U equals to 0, you can easily say that the Q is basically minus W from the first law of thermodynamics, right? Because the delta U equals to 0. So you can easily write Q is basically minus W, right? So this relation is true for isothermal and cyclic process. Now what isothermal process? Isothermal means where there is temperature is keeping constant. Temperature is no change of temperature throughout the process. That is called the isothermal process. So why we can say that is the temperature is constant in this case when the delta U is 0? Because you should know what is the formula of internal energy change. Delta U. Yes. Delta U basically CV, that is heat capacity at constant volume. CV into T2 minus T1, that is CVDT, that is CV into change of temperature. Now you all know delta U equals to 0 here. So CV cannot be 0, right? For a particular gas, particular temperature, everything is a constant. This is a heat capacity for at constant volume or a constant pressure. We can say these all are constant values. So it cannot be 0. So what can be 0? Obviously delta T is 0 there, right? So that's why we can say this is only true for this isothermal process. Also in some type of cyclic process also you can say, because there also you are ultimately you are coming through that position from where you have started your journey, right? In that way also same way that delta T will be equals to 0 also. Okay, so that is also true for this relation. So what we have got our information from this, that is about the process terminology. Yes, the process terminology, this all we have got our information from the first law of thermodynamics, right? So what we have got, just take 1 minute for the summary. Number 1, that is adiabatic change. Adiabatic, right? This is a process, adiabatic process, when there is no heat transfer, right? Number 2, isothermal process. That is constant temperature. Temperature is not changing throughout the system, right? Number 3 is isobaric. What is isobaric? That is constant pressure. What is isobaric? Isobaric is a particular process where the pressure remains constant throughout the process. Throughout the entire process, the pressure will be constant. Okay, so that is called isobaric process. Another one is isochoric. What is isochoric process? When there is volume is constant throughout the process. So constant volume. Another some processes are there. Number 1 is reversible process. What is reversible process? So reversible is a process, means a particular process, that means any reaction, physical or chemical, that can easily or after some time that can revert back. Revert back means completely revert back. That can completely come back to the situation from where that started once. Okay, so that is called reversible process. That may be any chemical reaction, that may be in physical change, everything that can be reversed when we can see the entire process again come back to the initial state. Okay, so that is called reversible process. So one important thing I want to share with you all, that reversible process is basically very slow process. It's a very slow process. So when we can say it's a very slowly a change of chemical or a physical change is there, we can see. So definitely we can say that is, it's a very 90% chance of that can be a reversible process. And what is irreversible process? Most of the cases, irreversible process has very fast process, first transformation, first change, very fast reaction, chemical or physical, everything. These all are irreversible process because these all are mainly very fast and it is what? It is a single step of reaction. So one more thing we should know, that is number one, fast reaction, and number two, single step reaction, single step reaction. These all are the features or the properties of what? Irreversible process. And what is reversible process? Mainly, those are slow process. And number two, those are mainly that contain so many steps of multiple steps of the process. Okay, so mainly the multiple steps contains there, not only single step. So multiple steps or infinity steps we can say there are. So that are mainly reversible process. Okay, so this is the main difference of all those things. Kirti also said something, ma'am, previous questions answer. Okay, Kirti, I got your thing. That is, you are talking about some work done, right? What I was saying there, that is PDB. So you were trying to say that, right? Okay, I got this. Okay, so now next move to our next part. Okay, now it's time to solve some previous year questions. So let's do it very fast. Anyone would like to answer this question, please? Okay, so number one, what is our first question? First question is, which one of followings are not the state function? You have to say which one of the followings are not the state function. Number one, that is Q plus W. Okay. Number two, you can see there is Q. Number three, W. Number four, H minus Ts. So you have to answer all from among all this. That is, there are options. You can see A, B, C, D. So any one of you want to answer this question? Okay, Nisha has answered 4. Ankita also answered 4. Kriti, do you want to answer? Okay, so we have got 2 answers till now. That is option 4, right? You want to answer option 4 means D. That is 2, 3, 4. Priyanka also answered B. Kriti answered 4. Shivani answered B. Okay, there are a lot of answers we can see. Okay, so let's check what is the correct answer. Okay, so this is the, we are talking about the state function, right? So number one option, whatever here is given, number one, that is Q plus W. What is Q plus W? Just we have studied. That is just remember the first law of thermodynamics. That is delta U, you know, U equals to Q plus W. So Q plus W basically nothing but change of internal energy or internal energy, whatever you can say, right? So that is, we are saying here not state function. Delta U is what? It is state function. So it cannot be our answer. So we can eliminate this. Number two, Q. Q is what? We have said there is only two path function, Q and W. That is not state function. So Q, yes, definitely it is a state it is a path function. It is not state function, right? Number three, W. This is also not state function. You all know this. Number four, H minus Ts. What is H minus Ts? What is here we can say? This is our Gibbs energy, right? G. G equals to H minus Ts. So G is gives energy, gives free energy. This is also state function. So here in question, this is not state function. So only 2 and 3. So what is the answer? Yes, option B. So option B is our answer. Okay, Ankita has given very good answer. And Priyanka, okay. These all are answers. There's so many good answers. There are so many right answers have given. I can see. So okay. So let's move to the next question. Okay. Number 2. So number 2 is, in a closed insulated container, a liquid is stirred with a paddle to increase the temperature. Which of the following is true? This also has came in 2002 NEET. Okay. So they are given such options. You have to say which of the following is true. So anyone would like to answer this? Please type in the comment section. Okay, Nisha answered B. Anyone else? It's a very easy question. Just think and answer. Okay, Priyanka also answered option C. Okay, so let's check what is the correct answer here. Nisha also hope, I hope this time correct, ma'am. Nisha answered B. Okay, let's see, Nisha, it is correct or not. Okay, so let's see. Okay. So the thing is, in a closed insulated container, a liquid is stirred with a paddle to increase the temperature. Which of the following is true? So here you have seen in the question that is insulated container, right? Insulated container means that is, the wall is basically adiabatic, right? So there is, we can say easily, we can conclude that no change of heat between the system and the surroundings. So Q is basically 0, right? Q is basically 0. So in the first law of thermodynamics, you know, that is delta U equals to Q plus W. So when Q is 0, you can say delta U equals to W, right? So here in the option A, it is delta E. Delta E is nothing but here internal energy change, okay? So U is termed here as E. So delta E is equals to U, not equals to 0, and Q equals to 0, right? This is option A. So here you can see whatever you have said, yeah, option A is correct, right? The option B, you can see delta E is equals to Q. Delta E means U equals to W equals to Q also not equals to 0. That is not hold good, right? Nisha, this time it's also you are wrong, but don't be upset. Don't be upset. It's just our trial session, right? So there, you already know 1 month is remaining for all of us. 17th July, the NEET exam is going to held, right? So you have now a lot of time, plenty of time. You can easily just answer. You can easily practice and go through step by step each and every topic. You can easily score very good. Okay. So don't be upset. Not the B. Option A is the correct option. And all other option you can say those all are not good. This all not hold for this question, right? Delta E equals to 0, Q equals to W not equals to 0. This is not also good. Q basically equals to good. This is not also correct. And also the option C, the D, it should be D. It's not correct. So only option A will be the correct option. Is that clear? Shivani asked a question. Reversible and irreversible process. Can you please explain, ma'am? Okay, Shivani. Again, I want to tell you one thing that what is reversible and irreversible process. So basically, reversible process means there is the name itself in the name or the meaning. There is everything the meaning you can say in the name, right? Reversible. So any process that either physical or chemical, if that can revert back to the initial state from where you have started, then we can say that particular process is reversible process. Or if any process that cannot revert back easily, once that converts to product, suppose in chemical reaction, once the reactants convert into the product and that never can come back to the initial stage or the reactant, then we can say that particular process, that chemical reaction or that physical process, we can say that is irreversible process. So most of the places, most of the state we can see, we can observe, these are the properties that in a reversible process, there we can see most of the cases, the processes are very slow process. Most of the cases, the processes are very slow. So reversible process, mainly that physical process or chemical process, whatever we can see, these all are very, very slow process. Okay. So you can see, suppose the change of state of water to liquid to solid and to gas. This all. That is the ice, the solid portion, right? When it converts into liquid, okay, that is water, the liquid state, and again that converts into the vapor, the gas phase, right? This is a gas, we can say gas. So this all change of the states of this matter, of this water or ice, whatever we can say, this all are very slow process, you can say. Not, you can usually say that suddenly the ice melts down and suddenly you can see the water is boiling or it is evaporating, like that. You can't see like that, right? It's a very slow process. So once it have to reach the particular temperature just to boil or the freeze, whatever we can say, freezing point or boiling point, whatever this thing. once that the temperature they will reach, only after that the state will change, right? So these all are reversible process. These all are reversible process. So easily you can already know how it is reversible process, because when the ice can be melted into the water or liquid, again that liquid, if you kept it in fridge, right, it will be freezed again, and it will be again converted to ice, right? So it is we can say it is a very good example of reversible process. So most of the cases, those processes are slow process. And number two is another property of reversible process, that most of the cases, this reversible process contains infinite number of steps. It is the maximum, actually, I am saying, mainly the multiple steps, that contains multiple steps. Okay, multiple steps, not single steps, because only in that way, in reversible process, we every time we use this integral sign, this integration, that is, there is very small changes of the process. Suppose we are integrating some volume, so there we have to take very summation of very small volume, delta v1 plus delta v2 plus delta v3 plus delta v4, like that, nth term, right? So that only in that way we have to use this integration sign, right? Summation of the whole steps. So that is what a reversible process. It consists of a multiple number of steps. When particular physical or chemical process that contains so many steps, not a single step, more than one steps, then most of the cases the possibility is that reaction or that particular process should be reversible process. And irreversible process means irreversible process, just reverse of that. Most of the cases we have seen, these are the fast process. So easily, just suddenly it is happening. First process means only in a single way, only single step is used, and the whatever the reactants, that is just converted to product, and that can never be coming back to the initial stage. So that is what we have seen, that is irreversible. Okay, so it should be fast and it should be multiple step containing. Okay, so now is that clear, Shivani? I hope now it is clear. Nisha, yes, ma'am. Okay, so you all got that. Okay, so now whatever we are now, we will end our today's session here also with one question. So which of the following is the correct equation? In the three option, question number 3, it is easily you can say, it is only depending on the first law of thermodynamics, right? You can easily say. Anyone would like to answer? Priyanka, for third question, option D. Priyanka said option D, that is none of this. And Ankita said option D also. Shivani said, thank you, ma'am. Okay, welcome, Shivani. It's my pleasure. Nisha also answered option A. Okay, so let's see what is the correct option. That is first law of thermodynamics, that is delta E equals to Q plus W. That is U equals to Q plus W. So only option A is correct, right? Not else. So B, C or D, everything is wrong. Okay, everyone. So our last question, today's last question, that is question number 4. So just look up on your screen and just look up on the question. A gas is allowed to expand in a well-insulated gas is allowed to expand in all insulated container against a constant external pressure of 2.5 atm from an initial volume of 2.5 liter to a final volume of 4.5 liter. The change in internal energy of the gas in joules will be what? Anyone would like to answer this? Nisha also answered. Finally, I have answered, ma'am. Yes, you have finally answered, and it's what's correct, Nisha. Okay, great. It's great, Atom, Nisha. Priyanka couldn't understand third question. Third question, which of the following is the correct equation? Priyanka, this is mainly you can see about the first law of thermodynamics, right? All of the answer, the options given you in your screen, you can see that all of those are about somehow we have just changed the sign convention of the first law of thermodynamics. We have shuffled the positions of U, Q, and W, right? So you have to recognize which one is the correct equation. Okay, so option A is the correct one. I think now you have understood. So what is the question number 4 answer? Anyone would like to answer? Ankita, fourth question, minus 505 joule. That is option B. Okay, Priyanka understood. Okay, so let's see which is the correct answer. Okay, so let's see. Okay, so here you have said that gas is allowed to expand in a well insulated container. So just look upon the question carefully. Insulated container means you have now have the information, that is Q equals to 0, adiabatic wall, right? Okay. So and also an initial volume from 2.5 to 4.5 and the external pressure 2.5 is used here. Okay, so when Q is W, what we can have the information from the first law of thermodynamics? That is delta U equals to Q plus W, right? So Q is 0 already, so delta U equals to W, right? Now, what is the formula of W? Work done. I have just said in the previous slide, maybe just 2-3 slides ago, maybe. So work done is basically if you don't have said, if you there in the question that is not mentioned about the work done on the system or by the system. If that is not mentioned, then you can easily use the general form. The general form is minus PdV. That is minus P means pressure into volume change, V2 minus V1. Okay. So just put down here the values, whatever you have seen there. That's 2.5 into V2 minus V1. You have seen that is the 2.5 to 4.5, right? 4.5 minus 2.5. So you will have the work done then. And if you have the work done, easily you can that can equal to delta U, right? Internal energy, that will be equal. So don't forget to use the sign convention also. If you just miss the sign, then the absolutely whatever you have got, either you have the correct answer, but it will be not correct because only if you have completed the clear the sign convention, everything you have corrected there, only then that option will be the correct. Okay. Okay, so now just calculate this. I don't know whatever in this answer, maybe if you calculate, maybe it will be coming to minus sign, right? It is minus 50 minus sign. What is 500? Option A will be correct answer. I think so. It is minus because you can see in this all these options are in positive signs, right? Okay. So only the option A is negative sign. You have seen here that is the W is in negative sign. So you can easily answer that is the option A will be the correct answer and all other you can easily eliminate. Okay. So hope you all understood this. Shivani answered option A. Yeah, Shivani, correct. Okay, fine. So whatever you have seen there, these questions are all for today's session. I hope all of you enjoyed today's session. So next day again, we will come back with another topic, very interesting way, and another questions also, so many things. There will be a lot of things, don't worry. So keep following this live session every day in this time. And don't forget to fill up the feedback form. Just it will be given in your comment section and also it will be given in your description box. Okay. So thank you everyone and all the best for your all the examination NEET. Okay. Thank you very much.